As you can see, I've added a few more components, but it's not really that bad. If I was just standing there switching these two switches, whenever I saw the light come on, I could make the light go on and turn off, draining through the capacitor as the gate drains through the capacitor, recharging the gate by turning the switch back on, turning it off again, letting the gate charge drain out through the resistor. When the light went off, I would turn the switch on again, over and over again. But I got tired of doing that. So what I did was I just put a little relay in there, a single pole double throw relay that exactly simulates me operating these two switches. Click, 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 click. So when the relay is not pulled in, the gate charges through the normal way. Through this red lead, through the relay, and then through the yellow lead to the gate. And that, of course, turns the MOSFET on, which pulls the relay in, which disconnects this wire, and then connects this wire, which goes over to the capacitor resistor set. So that allows the gate to drain out by whatever the time constant is that's set by this resistor capacitor combination, and then the light goes off. Okay, and the process repeats. So here then is our click rate control. So I'm turning it to the left now. Letting that charge drain off faster and faster, and now you can see it's not really building up enough even to turn the light on. So now I'm turning the resistor back to longer and longer resistances, which means it takes longer and longer for the charge to drain off the gate. So the light stays on longer, and there's longer intervals in between. The coil of the relay is simply in parallel with the light from the positive rail to the drain. That's the coil of the relay. So it actuates whenever the light is on. So, congratulations. We've invented the oscillator. So the duty cycle is set by the value of this capacitor, and the rate, then, the frequency, is set by this resistor. And if you use a different kind of a transistor, not a MOSFET, but if you use a unijunction transistor that has a more abrupt turnoff, you can get a more abrupt turnoff on the light. So when the relay is pulled in by the light being on, that discharges the gate through the capacitor, which takes a little bit of time. When the gate's discharged, the relay relaxes and connects the charging side of the circuit, which charges up the gate, which turns on the light, which pulls in the relay, which lather, rinse, and repeat. There's no diodes in here. I didn't even put a diode across the relay coil to protect the MOSFET because it's a 530. She can take the strain, Captain. A couple of 100-volt spikes coming back from that relay won't hurt the IRF 530N. But you might, if you were doing this with a different MOSFET or a different transistor, you would put a reverse biased diode across the relay coil so that returning spikes from the relay inductive collapse would be shunted through that coil and wouldn't make it into the MOSFET. I think this is pretty neat, isn't it? Just think, just from knowing a few basic principles of circuit operation, we were able to develop an oscillator on a Sunday afternoon. Thank you for watching.